Hi everyone and welcome back to NotesNaka. Today is day 15 of the lead coding challenge, and for today's problem we have maximum sum circular subarray. So in this problem we will be given an array that is circular as well. That means this minus 2 will, after this minus 2, this 1 will occur again. So that is the meaning of circular array over here. And in this array we have to find out the subarray that computes the maximum sum and return that sum. So in this one we can see 3 is the only element and that produces the maximum sum. So we return 3 and it does not even do it in a circular fashion. So there are two steps in doing this problem. First we have to find out the normal subarray sum, maximum subarray sum without considering it to be circular, and find out the maximum sum using Kadane'S algorithm. And again in the next step what we will do is reverse all the signs and find it again with Kadane'S algorithm, and then we will compare whichever is the greater one, we will return that. Now for a better understanding, let's take a look in pen and paper. So for today's problem we will be given an array and we have to find out the subarray that gives the maximum sum. We'll have to return the maximum sum of that subarray. So a subarray can be 5 3, minus 3 5, or 5 minus 3 5, but it cannot be 5 5. It should be continuous. And also in this problem it is considered that it is a circular array. So after 5 it is again the first element. Now to solve it, if it was a simple array, what we would do is use Kadane'S algorithm. Now what Kadane'S algorithm is that if it is a simple array, then we will have two values, current and total. So it will initially be 5 and total will also be 5. So these are 0, 1 and 2 index. So we will start a loop from 1 and iterate through the entire array and see each of the element once. And what we will do is one operation for this and one operation for this inside the loop. What we will do is find out the maximum of the current element and current plus that element. So a of I or a of I plus current, whatever gives the maximum will be our new current. So a of I is minus 3 and current plus a of I will be minus 3 plus 5, which will be 2. So our new current will become 2. After that, for total, what we will do is find out if the current is greater or total. So here clearly total is greater, so our answer will be 5. Now after that, for next iteration, when the index is 2, it will find out is 5 greater or 2 plus 5. So 7 is greater, so we have 7 here, and among these two 7 is greater, so our final result becomes 7. This is the answer and this is what is returned. So if this was a normal array, our answer would be 7. Now let's keep that aside for some time. Now since it is a circular array, what we will do is we have 5 minus 3 and 5. And from this what we will do is find out the entire sum. So the entire sum is 5 plus 5 10, minus 3 is 7. Then all of the signs will be reversed. So this will become 5, 3 and minus 5. Now Kadane'S algorithm will be applied on this subarray. When applying it on this subarray, what will happen is again we have current and total. So initially minus 5, and after that we will start from here 1 and 2. So for this one 3 or 3 minus 5 minus 2. So 3 or this. So 3 is our answer. And again after that this or this. So 3. Then we will have 3 minus 5. Again minus 2. So we will find out which is greater, this 2 or this minus 5. So minus 2 is greater, so minus 2 will be our answer. And this or this or this. So 3 is our answer after reversing the signs. So we have answer 2 as 3. Now we have two answers. Now what we basically have to do is the logic over here was, after reversing the signs, we had the sum 7 and our new answer is 3. So this is the 3 that we have to remove to get the maximum subarray sum in a circular fashion. So if we add 7 plus 3, then we will get 10, which is our answer. So what we are trying to do is, this was our sum initially, and then we found out we found out the maximum subarray sum when it is reversed. So after reversing, removing this, what are the remaining ones? Those will give us the maximum subarray. So in this, after removing minus 3, this is the one that will give us the subarray. So if we add them both, then we will get 10. 5 plus 5, 10. So we have this answer, we have this answer, and we have sum as 7. So we will find out if 7 plus 3 is 10 and answer is 7. So whatever is greater, using the normal Kadane'S algorithm or after reversing the signs and finding the answer, whatever is greater will be our final. So 10 is greater, so this will be our result and this will be returned. So this is the main working of this entire problem. Now let's check out the code. I hope you understood the basic functioning. Now if we look at the code, this is the code. So this is our main function. In this main function, what I have done is, first took care of the base case. So first I have taken care if all of the if each and every element is negative or not. So I have, if a of I is less than 0, then I have made a count which is counting if all of the elements are negative or not, and we will use this count later on. After that, I have made a new variable and I have called a function, and this function is k max subarray sum circular. So in this one, it finds out the Kadane'S, it is the Kadane'S algorithm, and it finds out the maximum sum of a subarray in a normal array. That means it does not take in account if it is circular or not. So after doing this, it returns the sum, and so we have that one sum in KAN. After that, we initialize a sum 0, which is finding out the sum of our array, entire array. And also we are reversing the sign at each of the sign of each of the elements. So a dot at I is equal to minus of a of I. After that, we initialized another variable seccan, means second can, and after that we again find out the new sum using the Kadane'S algorithm for the reversed elements. After finding it for the reversed elements, if count is equal to a dot size, that means if all the elements were negative, then we would simply return the Kadane'S algorithm's answer. We will not consider the circular array. But if that's not the case, then we will return maximum of can comma sum plus secant. That means if Kadane'S algorithm is greater or sum plus the new one, and this is what we had discussed on pen and paper. So we found out the sum plus whatever it is returned from this function, we add it, and whatever is greater, we return that as our final answer. So also this line, if count is a dot size, can be written somewhere over here before doing all of this. That would save us some time as well. Now if we run the code, you can see 10, and if we submit, then it is accepted. So this was today's question. We have to take care of the negatives, and if we don't, then it will surely give us a wrong answer, and so take care of the base cases and all. And I hope you liked today's video. If you did, then do give us a thumbs up. Also subscribe to our channel, and if you have any feedback for our channel, please leave it in the comment section below. Thank you for watching and have a nice day. Bye bye, take care.